Assalamu alaikum. My name is Saaim Siddique, and today my topic of presentation is interference and diffraction of light and its applications. First, we are going to talk about interference of light. What is interference of light? The phenomena in which two waves superpose each other. Means, what is the meaning of superpose? First, we talk about superposition of waves. That what is superpose? When two waves or more waves meeting each other at same point, you can see here that two waves are meeting each other at same point here. So we get a resultant wave. So this is superposition of waves. And the amplitude of the resultant wave is algebraic sum of individual wave. You can easily see here that the amplitude of this wave is equal to the sum of the amplitude of these waves. You can easily see here. This is the superposition of waves. Then you can watch here that how these waves are superposing each other, and we are getting interference pattern here, and we are getting the phenomena of interference here. Then there are two types of waves. There are two types of interference: constructive interference and destructive interference. First we talk about constructive interference. When the maxima of two waves add together, you can see maxima of two waves. When we get the sum of these maxima, or we will get the sum of individual amplitudes. You can see this. We're getting sum of individual amplitudes when we get the sum of these maxima. This is known as constructive interference. Then we talk about destructive interference. What is destructive interference? It occurs when the maxima of two waves are 180-degree out of phase. 180-degree out of phase means that when the maxima of one wave is positive, the maxima of other wave is negative. Hence they cancel out each other, and we get the amplitude which is equal to 0, means the amplitude of resulting wave is 0. So you can see easily here, this is destructive interference. So this is destructive and constructive interference. Then talk about applications of interference. Number one application is anti-reflective coating. It is done on camera or glasses. Because of it, the intensity of reflecting light reduces. Means the intensity of reflecting light reduces when we use anti-reflective coating. You can see in this picture, then you can see in this picture, the picture is very clear from the side of anti-reflecting lens, and picture is blur from the side of ordinary lens. Because anti-reflective lens is reducing the intensity of reflecting light. So this is number one application. Then we talk about application number two, optical flat. That what is optical flat? They are used with monochromatic light to determine the flatness of other surface by interference. We can use optical flat with monochromatic light. Monochromatic light means that the light with one color. So we can determine the flatness of the surface and of any other. Uh, we can determine the flatness of the surface by interference. Application number 3: thickness measurement of thin films. We can measure the thickness of thin films by process of interferometry. This is a process which we can determine the surface thickness, including thin films also. So this is the powerful mean to measure the thickness of thin films. Then the other topic is diffraction of light. What is diffraction of light? Bending of light from any sharp edges or corner. You can see here that light is bending from these sharp edges or corner. This is known as simply diffraction of light. There are two types of diffraction: Fraunhofer diffraction and Fresnel diffraction. What happens in Fraunhofer diffraction? In this diffraction, source of light is far away to screen. You can see here that source of light is really far away to the screen. You can see the sign of infinity here, means you can say at infinite distance. Incident wave fronts from diffracting obstacles are plane. You can see incident wave fronts. Before diffracting obstacles, these are plane. And after diffracting obstacle, this is diffracting obstacle, and after diffracting obstacle, these are also plane. Means diffracting obstacles give rise to wave fronts which are plane. Then plane diffracting wave fronts converge by mean of convex lens. We use convex lens to converge the wave fronts to produce diffraction pattern. After a convex lens, you can see that they are diffraction pattern. They are the spherical wave fronts. There are spherical wave fronts. So this is Fraunhofer diffraction. Then we talk about Fresnel diffraction. That what is Fresnel diffraction? In this diffraction, source of light is close to screen. You can see that source of light is near to the screen, and incident wave fronts from diffracting obstacles are spherical. You can see that the incident wave fronts are spherical from diffracting obstacle, and after diffracting obstacles, these are also spherical. You can see after this. Diffracting obstacles give rise to wave fronts which are also spherical. You can see wave fronts after diffracting obstacles are also spherical. There is no need of convex lens because we are getting the diffraction pattern without convex lens, so there is no need of convex lens. Then applications of diffraction. Number one, determine crystal structure. We can determine the structure of crystal by diffraction process. By you are seeing this picture, we can find this type of structures in the crystals by diffraction process. Number two, holograms, recording of an interference pattern by using diffraction to get 3D light field. You can see we are using diffraction process here. We are getting 3D light field here. So recording of an interference pattern. We are recording of an interference pattern here. From door corners, you can see bending of light from door corners here like this, as we have seen the definition before. So we are talking about this from door corners. Number 4 application is separation of white light. You can see that white light is separating from here, and we are getting spectrum here. So when white light can be separated into all 7 major colors. of the complete spectrum or rainbow by using diffraction process, by using diffraction grating. You can see the diffraction grating here, and we are seeing diffraction process here. So this is application number 4. Application number 5, CDs, compact discs. So CDs, data of CD is stored in microscopic pits. Here are some microscopic pits between these patrons. So between these CDs, so they are on different lengths, which carries information in the CD. These pits are placed in a row of the same width. They are placed in the row of the same width on the equal distance. So we get the diffraction grating from here, and we get spectrum on the CD surface. So by diffraction process, we get the spectrum on the CD. So these were the applications of these is these were the applications of diffraction. So this was my topic: interference and diffraction of light.